Greetings, STEM 2 students. The topic for today's video is angle and arc relationships. I'm going to first have you record the 4 formulas that we're going to do on this page, and then we're going to do some sample problems together. Okay. I want to make sure you understand the difference between the types of angles and how you can determine which equation to use. So, first one is when the vertex of the angle, see x is in the interior here. When this vertex is inside the circle, then we're going to consider this an interior angle. All right, and so notice A is going to be an arc, and arcs are really just the curved part of the circle. Okay, B is also going to be an arc, and X is going to be the angle, just an angle. And then I'm going to just put one other note up here for arc. These are what are called intercepted arcs. And let me show you what that means. An intercepted arc is really just like if you have a circle with an angle created on the interior. I always think about like the angle forms a mouth. The intercepted arc is just this part on the inside of the mouth, if you want to think of it like that, that it looks like it's going to get eaten by the angle. Okay, so if you extend the lines of the X right here, this B would be an intercepted arc, and the same thing on this side. A would be an intercepted arc, and then X will be your angle. All right, and the formula is pretty simple. X is just an average of those two angles. So we'll say X equals A plus B all over 2. All right, and that's going to be for interiors. All right, now if you scroll down or if you look at the next equation, notice that X has the vertex of its angle existing on the exterior. And so exterior angles is when the vertex is outside the circle. Okay, so once again, A and B will be the intersected arcs. I'm going to be a little bit more specific. A is going to be the larger arc. B is going to be the smaller arc, and X is going to be the angle. And so very similar formula. The difference is when it meets outside, instead of adding, you're going to subtract to find X. So I'm going to take the bigger angle A minus the smaller angle B, and then divide it by 2. The third angle is what's called an inscribed angle. And inscribed angles have a relationship of half the intercepted arc. And so I'll say here, A is going to be considered the intercepted arc. X is going to be the inscribed angle. And for inscribed angles, notice where the vertex is. It's actually right on the circle, like right here. So we'll say with inscribed angles, the vertex is on the circle. Okay, and this formula is going to be the same for both of these situations. I just tried to show you what variations you might see of this setup. Okay, so X, that angle is going to be half the intercepted arc. So half of A. So if you like that in words better, we'll say the angle equals half the arc. All right, and I actually saved the easiest for last, the central angle. It's identical to the arc. So if A is the arc and X is the central angle, these occur when the vertex is at the center. Okay, your relationship will be that they're equal to each other, A equals X. So if this is a 90-degree angle, this is a 90-degree arc. All right, so now we're just going to classify, and then we're going to figure out what kind of equation to use. I'm going to solve for X first, and the reason I'm going to solve for X first on this one is if you look at where the angles that they labeled for us exist, these arcs are intercepted by angle X. And so X has a vertex that's on the interior. So this is going to be considered an interior angle. And our formula for that is A plus B divided by 2. And so basically it's just an average of the two arcs. So X would equal 180 plus 80 divided by 2. Make sure if you're using a calculator, make sure you don't, make sure you press enter after you add the two numerators together. If you try to do this in your calculator and you don't press enter after the 80, it's only going to divide the 80 by 2. So if you add the numerator, we get 260, divide that by 2, and that's 130 degrees. Okay. Now, if you look back at the picture, these two angles are supplementary. Oops. All right. It's not going to let me draw that. Well, X and Y form a linear pair. So we know that if we add 130 and Y together, we're going to get 180. And so Y would have to be 50. Oh, gosh darn it. There we go. Y equals 50. Okay. Let's see. The second one, X is an exterior angle. So instead of adding the arcs, we're going to subtract the arcs. So I'm going to say X equals A minus B all over 2. All right, now you're probably looking at this going, okay, I think Miss Markley, I think you forgot to give us an angle. Well, I really didn't actually forget to give you the angle. What I want you to notice is when you see a diameter like this, you basically have half the circle above it and half the circle on the other side. So that means together, this angle plus the 60 have to add up to 180 degrees. So what's left here would just be 180 minus 60. So that's 120 degrees. All right. And so if you kind of think about this angle like the mouth, the 120 and the 60 are going to be the two angles we subtract. You're always taking big minus small. So we're going to do 120 minus 60 and then divide that by 2. So X would equal 60 divided by 2 is 30, and you're done. Okay. Number 3, if you notice, it's very similar to number 1. This is still considered an interior angle because our vertex is on the inside. So we're still going to add the arc. So I'm going to put it in words first. So I'm going to say angle equals arc plus arc divided by 2. And this is basically just going to turn into an algebra problem. Okay, so the angle. Well, my angle here, we actually know it this time. So we're going to say 105 is our angle. That has to equal one of the arcs, which is 120, plus the other intercepted arc, which I don't know. So I'm going to put X all over 2. Well, if we're going to solve for X, we just have to do PEMDAS in reverse. So I'm going to multiply both sides of my equation by 2. So then my 2's cancel out. So on the left side, we get 210 equals 120 plus X. And then if we subtract 120 from 210, I believe that's 90. So X would be 90. And I always double check when I'm done to make sure that this number is an average of the two arcs. So yeah, so if you had 120 on 120 degrees on the left and then 90 on the right, 105, that angle that's on the interior should be an average of those two, which it is. All right, let's see, number 4. Again, very similar in structure to number 2, but I want to show you some of the different ways the algebra is going to turn out. So this is going to be considered an exterior angle. All right, so similarly, we're going to say our angle is equal to arc. I'm going to say big arc minus small arc. And then we're going to divide that by 2. So all over, oh, that was weird. All over 2. All right, so let's come up above. So the angle that we see here is 13 degrees. Okay, the big arc, we don't know, so I'm going to call that x, minus the smaller intercepted arc, which is 20. And the formula says divide that by 2. All right, well, it's very similar to the last problem. We're just going to solve for x. So I'm going to multiply both sides by 2. So we get 26 on the left equals, the 2's will cancel, x minus 20. And if we solve for x, I'm going to add 20 to both sides. And we get 46. And that's it. Okay, so a couple strategies. Definitely look for these angle pairs that I showed you here. Also look for diameters. You know, they're not always going to like clearly come out and say, here's a diameter. But if you see that, you know, there's a line that passes through the center, they're going to cut the circle into 2 groups of 180 degrees. 2 groups of 180 degrees. And a lot of times you'll be like, oh, I can't find any angles. They didn't give me enough information. Usually that means there's a diameter that you haven't remembered to look for. Okay. The other thing I would suggest is fill in all the parts of the arc if you get stuck. And you know, a lot of times just remembering the basic fact that if those arcs add up to 360 degrees, full circles 360 degrees, a lot of times you can find some information out. Okay, we're going to do just a couple together on this page. At this point, if you want to stop the video and do it yourself, you can. But if you get stuck, you can come back. I'm going to work through, I'll just tell you which ones I'm going to do. I'm going to do number 1. I'm going to do number 5. And number 7. Oops. And number 8. So if you're confident and you think you can figure those out, actually, no, not 8. That was 10 here. I'm sorry, 10 is the one I wanted to do. Okay, so if you're confident on those ones, go ahead and stop the video. If you get stuck, you can always replay it and watch those questions. So thanks for watching. Let's see, number 1, you're going to use this idea that the central angle is the same as the arc. And so this, the directions say which kind is it. And so this, for part A, I'm going to say it's a central angle. And then they also want you to solve it. And there's not a lot of thinking here. It's the exact same as the exact same degree as the arc. So that's 48 degrees. All right. If you look at number 5, 5 is an inscribed angle because the vertex is on the circle. You'll probably have to keep flipping back and forth on the other side of your notes to reference what kind of angle it is. But once we decide it's inscribed, it's either half or double. And here's my really gross example to help you remember this. If you know, let's see, how do I want to say this? If you know this arc out here, think of this like food. As you eat it and it goes to the back of your mouth, here it gets smaller. So that's the same thing that happens with these arcs. Okay, so on the picture here, X is the amount of food we started with. As you choose it, it gets smaller. So this is already half. That's already half of what we started with. So if you want to find out the original amount, we would just double that. So the arcs always double the angle. So 58 times 2 is 116. If that confused you, just use the formula. You're going to do, let's see, where was that? Yeah, the angle is half the arc. So I would say, oh, sorry about that. Got a reminder. angle is half the arc. So that would mean that 58 is 1/2 of x. So if you wanted to solve for x, we would just multiply by 2 or divide by 1/2, and that's where we get 1/16. Okay. Number 7 gives us a setup that we have to solve for an exterior angle. So I'm going to put that here. But the problem is we don't have the measure of this arc. Well, if you look back at the clues I give you, usually, if you're missing information, it comes down to either looking for diameters or the 360 total idea. So here, there are 1, 2, 3 parts of the circle that we know. I know all of these have to add up to 360. So I'm going to add 110 and 130 and 80 and see what I've used. So that looks like, what is that, 240. Looks like we've used 320. So if we've used 320 degrees, that means this missing arc would have to be 40 degrees. All right, now that's not the angle, but that's this curved part. So now that I know the two arcs, I can get my angle by taking big arc, 130, minus the small arc, and then dividing that by 2. So 30 take away 40 is 90. 90 divided by 2 is 45. Okay, now the last one here, again, we're going to use this, we're looking for this inscribed angle. So I need to know this arc that is cut off by that angle. So again, the 360 total is going to help us start this. So we've used 212 on the left. So that means this arc would be 360 minus 212. So that's going to be, what is that, 148? All right, and now that I know the arc, the angle is going to be half as large because that's this one right here. So like if this is 100, we got 50 on the angle. It's always going to be half when you're moving in. So 148 divided by 2, x is going to be 74, and this is an inscribed angle. All right, your job is to finish the front in class, show it to me, and then to do the backside for homework. Thanks. Bye-bye.